Hello, welcome to this Renderman tips video for volumes. It took quite a long time for me to move over to the volume topic. This was because I have waited till some of those issues with Renderman volumes were fixed. The Pixar development team has fixed those issues, and Renderman 23.5 is, in my opinion, the magic release for volumes. I describe in this tutorial the way to go with Renderman 23.5, and the speed increase is really drastic and you should take a look at it. So in this tutorial will be divided into two parts. The first part will cover the basics on how you will be able to render volumes, and the second half of the tutorial, the more advanced user part, will show you how you can get very clean results. I will also cover an Lightcloud add-on, or I will not say add-on, but asset for Houdini, where I show you what you see right here on the screen. It's a very nice looking explosion. There's no noise anymore, and even this is the denoised variant, and even the undenoised variant, that the overall quality is really great, and I will show you in the second half how you do that. Also, the render times are drastically reduced in this with this add-on or with this asset. And yeah, when you like the overall quality of Renderman volumes, you should take a look at it. I have a CPU from 2014, and the longest frame of this animation took about 10 minutes with a very nice resolution. And it also has those new trail tools, and I will also show you how you can use those new trail tools from Houdini 18.5. So yeah, so let us move over to the tutorial. Here we go. Hello, so we start into the first section of the tutorial, which I show basically how you can render a basic volume. So you will learn all the basics to do that. And what we do first is we create a camera in this new scene. So this is a plain scene. I have a special desktop for that, or window configuration in Houdini, which is for Renderman, so that I can have the render output directly available right here. And to get all the basics for the render, the integrator, and so on, I hit the IPR button once, and then I will stop the render process again. And now you see we have the path tracer integrator, the wrist node itself, the camera is linked, and so on. And what I do first is I will copy the maximum samples in the wrist settings, in the render settings, to the minimum samples. And I will divide it by 4. And then I will take the minimum samples, copy the parameter, and copy it to the extra minimum samples, and will also divide them by 4. Those are my basic settings. What I also do and highly recommend for rendering and denoising Renderman in general is to do a sample offset, which is varying the sample distribution on each frame. This should work automatically. However, there's a bug in Renderman, and yeah, because of that we had searched for another way to do that, and this is plain simple. You type rend for random, and you use the $f attribute for frame and multiply it by some weird number. You close the section and multiply it again by a certain number. So when we move down our animation, you see in each frame we have a totally different sample offset. So maybe we can lower it a bit, that we don't have that high numbers. So this is highly important for denoising volumes too. Yeah. So of course we need a volume, and I will go to the pyro shelf and we'll add a billow smoke, plain simple. We need a sphere for that. Make it a bit smaller, maybe half the size. And now we have a volume. What we currently don't need is the animation itself and all this, so the simulation, we don't need that. And okay, this is the volume, the source object. And what I do now is I connect the render output to the rasterizer. So what we do now is we only want to render this volume itself. What I also don't need in this presentation or demo is the noise, so that we have the temperature and also the density itself. And yeah, for now. When I hit render now, you will see that we only get a box. This is totally normal because you don't have an auto applied material like you would get in Mantra. So I will stop the process of rendering and we'll go to the material tab and we'll create a new Pixar material builder. I call it simple volume. Simple volume. And I will create inside a new volume, Pixar volume material, or this node Pixar volume, and we'll connect the BXDF output to the shader input, or to the collect input. What will happen now is basically when you hit now the IPR, you see just the box. This is totally fine, this is totally normal. What we don't did yet is to assign the density field. So when we go back to and see the attributes, or that the fields that we see we have a density field and the temperature field. And we need to apply the density or the temperature. But of course, in general, it's the density. We also see that it's already a VDB. So in case you work with ordinary Houdini volumes, make sure you convert them to VDB. It's not necessary, however, it will render much faster, and also updates will calculate much faster. Under the hood, Renderman is working on VDB basis. So we go back to our shader, simple volume, and we will type to the density float prim variable, we will type density. So this has changed now, and when you hit IPR, you see, oh, of course, we need to apply this material. And we also need to add the spare parameters, highly important. We need to apply this material. Here we have it. And now you see we have the volume. What is when I don't type the density float variable into that? I will do this now, and you will see we get a weird looking box which has some form of opacity ramp in it, and this is because Renderman is able to render every geometry as a homogeneous volume. That means when you don't use this density field, you can convert, or Renderman will convert the geometry to a homogeneous volume, and you can change the density by altering the extinction distance. So at 0 it uses its default, but when we go to 0.1, you see it will become more or less a total untransparent box again. And when we will raise this value, let us say to 100, you see it's going much thinner. So yeah, we don't want to do that for now. So I will go, yeah, you can basically go back to the defaults. You don't have to. We go back to the density. And here we have it. What if we want to render the temperature field itself? What we can do is we can, of course, raise the emission color, or we can link something into the emission color like a density field. And yeah, this is the way we have to do this. So you create a Pixar prim variable, type prim and get a Pixar prim variable, and here we type temperature, and then we will connect the output of the result RGB to the emission color. Of course, source object has no big variation. It's more or less the same like the density itself, but I can maybe raise this to 100, and I will look, or we will look how it will look. We currently have only a float temperature right here, I guess. So yeah, it's a float value. So as long as you don't have a vector value, you have to use the float vector option and you get it. And the problem now is, how do you shade that? You can, of course, use the color corrector like I said, and can change, oh, that was the wrong one, and shade how it will look. The ordinary way would be to connect a ramp to it. I will show it later when we deal, or you will see it much better when we deal with the shading a fireball a bit later, but this is the basic concept. So you can type a color right here. Maybe we can go to here, and of course you have to apply, yeah, you see it, it's got colored by the temperature itself. Later in the fireball example you will see it much better, but this is the basic way to go for shading a temperature field or a color field too. So, but we also have to sometimes use velocity and densities. And when you want to use the velocity field for motion blur, you have to outsource the velocity field, temperature fields, and so on. You basically have to outsource them. So what I will do now is I will create or duplicate this prim variable, and we'll type v for the velocity field, which we currently don't have, but we will create one. And you also have to outsource this density field right here. So you can copy that, you can erase that too, and I will go to here, it's a float value always, and we'll connect the result f float to the density float. And for the velocity we have to change it to vector, and we connect the result RGB to the green input, to the velocity input. I will also raise the velocity multiplier by 10. I did that because the Eulerian method, or Eulerian volumes that Pixar has introduced in 23.5 requires to match this value with your camera speed or animation speed to have physically correct values. You find more information on that in the Pixar Renderman documentary for Renderman 23. So here you have an entire section only about those Eulerian technique, which is now supported. The advantage is it has a much lower footprint, and it's updating very fast, and yeah, it's much better than the Revis method technique that Renderman has used on default in the past. I will do some motion blur now. So we go to the render tab, to the render settings, and I will stop the process and I will hit the allow motion blur. It's highly important that you have more than one geosample, because this volume, even it's not a geometry by definition, it's a volume, but you have to raise the geosamples. I set it to 3. And then we go inside this volume again, and I will add a velocity attribute. So I hit the plus button right here, go to velocity, it's called V, and it's already a vector attribute. So sometimes when you create a volume based on one of those fields, you get float values. So you basically get something like Vx, Vy, and Vz always as a float. But this is not working with Renderman. So in case you have that, I will show you later again. In case you have that, you use a vector merge, where you basically define those field names for all the floats, and then you get out a new vector VDB. This only works with VDBs. So this VDB merge is only working on VDBs. So in case you have an ordinary Houdini volume, you have to convert this ordinary volume first to VDB. So we go to here, and we will dial down those values, and we only want to have a volume direction into the x-axis, into the right direction, and I will scale that up to 1. I will check how it will look with I push the X shortcut on the keyboard, and then you get the eyeball, and then I left click to the geometry source or to whatever node you want, and you get a new visualizer. We don't have to deal with it now. We can also check this probably here when we set it to volumes and set the source group to V, and then we go to visualizers, vectors, and here we have it. Positive X is on the right, and the velocity is also moving to the right. So we have it. We are sure we have it. So I will go here, and then I will go to our material. We will check if we have it. We have our velocity here. It's called V. It's a vector. It's connected to the velocity from the pink output. And then we hit the render button, and hopefully we will see something. Yeah. So as you can see, it's much darker right here. When I change this value now to 1, you see it has slightly moved. As you can see, the volume gets some motion blur. So this is the way to go for dealing with Eulerian motion blur. And yeah, you see it is working. So, and what is when we want to have some color in our volume? So I have disconnected this for now, I will go here and will create a new volume based on this old sphere. I use the color smoke variant. It's created now. I will also play this animation quite a bit. So we have some nice looking stuff right here. I will go to the, I will of course deactivate the source. We don't need the source now. I will select the pyro import. This is the volume we want to render. I will hit the add spare parameter again. We need this parameters on the volumes. I will apply our symbol volume, and I will dive down into the pyro import and we'll check what we have. So this has the render flag, the purple one. And for now you see it's a volume, an ordinary Houdini volume with velocity x, velocity y, velocity z, cdx, cdy, and cdz. What we have to do when we want to use the velocity field and also the cd value, we have to convert them and to merge them into a VDB. And this is what we do now. So I will create a VDB convert or convert VDB, and we'll convert everything to a VDB now. So what we have now is we have 10 VDBs. I will drop down a null and we'll call it render and set the render flag to it. So this is always what we get from the render view. If you don't know this, when you push the control button and select the display flag, you will get a purple one. This will give you the render flag. So this is rendered only. So back to the convert VDB, and what we have to do now is we still have those float VDBs right here. We have to merge them to vector VDBs. So I will drop down a vector merge, VDB vector merge. I will apply it here and we will go there, and you will see it automatically has merged the CD value and also the velocity value. So this is what we need. When we go back now, so this is the automatic way. You get a warning because those components have different grid transforms. We could do it basically one by one, but yeah, we don't need that. It's just a warning, it will work. So we will go back, we have it here, and I will hit the render button, and now we want to see what we got. We have the volume, it looks correct, and I will go to the shader back and we will look to the volume. The velocity field is now called val and not v, so we will call it val, and you will see it has moved slight a bit. No, it doesn't has moved. So now it has moved a bit. Yeah. So did you see that? I will stop the process and will hit again the render button so we can dial down in the catalog. So I will go to 10. We'll restart. So this is the value with 10. And this was the value without the velocity. So here you see the velocity is working. The volume gets pushed into the correct direction. So this is working, and we also want to apply the colors. The color is a vector, so we type CD right here. Our field is named CD. And we will connect the result RGB to the diffuse color. And now you get a black one. Because the variable is set to float, we needed to set it to color. And now you see we have the color. What I also will add is I will create a new pixar light, a distant light, and I will rotate it a bit, like here and there, and we'll raise it to exposure of 2, I guess, or maybe 3. Yeah, so we have some light from a light source. I will create also a ground, a grid basically. I will add the spare parameters to the ground and will create a fast ground material. So basically copy this, call it ground, it's much faster. And here I will delete all that stuff. And we'll call it pixel diffuse. We only need the diffuse for the ground. And I will apply this material, ground, so we have it. And now you see our volume is quite thin. We will change this now in our simple volume shader. You can also use a pixel color corrector from here to result RGB to here. Maybe so we have raised the density from the field. So this will not work anymore, more or less. So you have to do this in the stream itself. We could also use a remap, but you see it's really fast. Also with velocity, I mean, we have velocity activated and we still get a decent result, a very fast result. And the ground or the volume is stucking into the ground and we don't like that, so I will move the grid down a bit. So I hope this looks better. Yeah, so we have a slight gap between the volume and the shadow itself. What we can do now is we can go back to our volume shader and we can look at those options we have. So we have an emission field, so we can basically use a temperature field. I guess I can do this now. We have a heat attribute, of course. I will copy this, I will set it to float 1. So, and we'll use the temperature. I will connect it from the pink result RGB to the emission color. We will see we get some tiny illumination inside of the volume. I will create a ramp, a pixel ramp. We'll connect the result F to the spline. We'll reconnect this one. And we can use the black one. We will use the white one here. We'll add some yellow to this one and some red to this one. So we have some tiny sort of flame fake effect. So here it's much brighter. And yeah, I will also drop down a pixel color corrector. Nice thing on Renderman is that Renderman behaves something like a compositing program, a 2D program like Nuke or Fusion. When it comes to volumes or in general to shading, this is quite nice. So you drop down a color corrector and raise the exposure, and you see we now have some sort of flame based on this ramp. We could also use a remap in between, and you see we still have velocity activated, 3 geosamples, and it's updating more or less in real time, which is quite awesome. So, and we are able to do a remap here, a slight remap, maybe a drastic one, and this one. So we can play with that in real time. We don't have a totally wide value currently. So that's the way to go. Yeah. So in general, when you want to shade a flame and you want to have a good looking distribution of the illumination on the ground, you should always use, so the default method is to use the light source option. This will basically create some sort of volume emission field automatically, or every voxel will get turned into a light source based on the emission volume. Of course, you have to raise those volume to get some sort of effect, and you have to use very realistic values, and you see it's not really working nice. One of the reasons why I don't like this option, it's quite complicated to use it, so I deactivate this option most of the time. It will create some sort of noise, maybe 10, it's too much, 5. Yeah, you get some sort of illumination on the ground, but it's very calculation intensive, and in order to get this working right, you have to consult the documentary and also the tab right here. I don't use that. I don't recommend to use it. Also in the second part of the tutorial, I show you a way which will produce much better results with the asset that I've built. So yeah, I don't go into the details, because also for me it's not working always in all conditions. It's for me it's a pain, so I don't recommend to use the light source. However, I will dial down the emission exposure, or the exposure of the flame, or maybe we will deactivate it to show you something, the other options. So we also have the multi-scattering ability. Multi-scattering is how the light is moving and bouncing off in the volume itself. So when I turn it off, you see it's much darker right here. When I activate it, you see much more light will contribute it through the volume itself. You can optimize your render times by activating multi-scatter optimization, and this also provides the ability to change those contributions extinction multiplier. So I can raise it to 10, and you see much more light is moving through, and also much more light is bouncing off around. So the light is basically coming here, and moving out of the volume, and will illuminate the entire surrounding, all your geometry and other volumes that you have around. This is one of the biggest benefits of this multi-scattering option. So you can create a volume inside or in front of a window, and the light will pass through those volume and will illuminate the entire room. This is a really nice feature. As you can see right here, you can multiply how much light will emit. To describe it, you have a ray which is coming here from the right, which has the value of 1. It's moving through, and on each intersection with another voxel, it gets a multiplication of 100. So from 100 to 200, 300, 400, 500, and then it will go out of the volume at some certain point. So this is in general how it works. And we also have a sampling tab right here. where you can see two very important options, the minimum samples and the maximum samples. Both values are deactivated as long as multiscattering is activated. So you can set what you want, but you will see no difference in rendering only when you deactivate multiscattering. And for ordinary smoke, you don't need the volume scattering option. You only need to use the anisotropy and the sampling. And this can help you iterate much faster. So I can dial down the minimum samples and you see it's updating much faster. And this is basically a way to optimize the quality of the volume itself, or how fast it converges and how much. So step size has no meaning anymore. So I can go to 9 and it will sample down to 9. When I raise it both, you see it's very slow, but it will apply 9 samples on each iteration and will look quite nice. So the defaults are 4x4 or 2x4 is what I use on single scattering volumes. And then we go to the anisotropy, and here you can basically define how the light is scattered through the volume, or how the single scattering is working. You see this is not working currently because you have a blend factor. When you dial it to 1, only the secondary anisotropy is used. When you dial it to 0, only the primary anisotropy is used, and on 0.5 every value is used by 50%. So this will enable you to give the volume the shading you want to have. As you can see, when I activate multiscattering, you see it converges, or it looks like it will render much faster. This is also a fact. Multiscattering is in some cases rendering faster. I use it quite a lot, but however it will look much more noisier. It's really depending on your light sources and so on. If those light sources aren't too bright, multiscattering will benefit your render times. If you have a large cloud on a sky setting with a very intense sun lighting, multiscattering will not really benefit your render times in comparison to quality, of course. On the other side, this multiscattering value is influenced by your render settings. On default, the defaults are right here below the allow motion blur settings. You have this single tap. I think Pixar should move it to a much or to the sampling tab itself, maybe right here, because right here it's so you can overlook it. So it should be moved right here, maybe. The max diffuse depth is how much the light will bounce off in the volume itself. So when I raise it to 7, you see the volume gets a bit brighter because the light is moving much deeper inside of the volume. However, this value is limited by your integrator settings. So when I go to the Pixar tracer or the Pixar path tracer, you see we have a maximum indirect bounce value of 8. You can raise those values to 10 with a limit at 8 and it will still render at 8. So for a realistic cloud, for example, you need at least 20. I recently heard that some artists are using 100 or 150 in some productions to have a realistic looking cloud. So you can raise it to 100 and then you go down and go here, let us say to 100. it will look much more correct, but also it will render a lot slower. Also, the render time will increase with more voxels. So more voxels and it will increase on that amount of bounces. Yeah. Oh, now I have moved it. No problem. It's not crashed. So here comes another problem with motion blur. So this is what I expected. You see that the volume is clamped at the outer bounding box right here. And this is because the Eulerian volumes that we are more or less transforming with the velocity field need or require a much larger bounding box. So I guess this is one of the reasons why it looks clamped. I'm not 100% sure in that case, but in general, according to the documentation and according to my test, you go right here into the pyro simulation, and you have to raise the resize container. You have to raise the padding. It's okay when you have a velocity right here in with that value, but let us say your velocity is much larger and would expand to this area, it would be clamped on the bounding box. You can either raise it in the resize container when you have a simulation done. You go here and raise the padding itself. This would work. And on the other side, when you still have a volume which is not simulated, you can create a node called VDB activate, and in VDB activate you can go to the expand tab and can raise the padding itself right here. This is also a way to go. So you can do both basically. So we can resimulate that. It will move up right here. I will hit the render button. You see it shouldn't get clamped now. I think it's the resolution. Resolution isn't not sufficient enough. Yeah. You see it's clamped right here and we have motion blur on it. So I will try to do the activate right here. I don't know if this is working. Maybe I can try that. Okay, it's working. So hopefully this will do the trick. Restart the render process. And now you see the clamp is gone. So I will deactivate it. You see. Okay, I have to restart. You see, you get a clamp because of the velocity, and with a VDB activate, you can get rid of it. Restart, of course. And now you see the clamp is gone. So this is the way to deal with that. And yeah, as I said, it's quite fast to change those shaders now, and of course also to raise the velocity values more or less in real time. I mean, isn't that awesome? Changing the velocity itself without any time-intensive recalculation process. So I will reconnect the temperature field too, so we have some fire in it. Well, this doesn't make any sense. Maybe we can raise this value to 4, so we have some sort of fire in here. That's the way to go. So what we do now is I will show you now how you can shade a pyro flame. So I will go here and I will basically kill off this simple volume, or maybe we don't need this now. I will also delete this entire simulation. We don't need this for now. This also, and here we have our source emission. I will create a new explosion, and I will run a fast fireball explosion, some sort of, and we don't need this Mentra shader. And I could, of course, this is our render volume. I can, of course, apply our shader, but you will see it will not look correct. It will not looking right in any form. Yeah, maybe a bit because of my ramp, but this is not really what you get by default. So when you create or when you follow the default instruction of the Renderman page, you will see that this is not the way to go for most users. So Pixar has set a tutorial page shading a fireball inside of the Renderman 21 documentation. And when you dial down right here, there are lots of good and important information. But when you dial down, you get an example file, which is basically this one, explosion v5 hip file. I have already downloaded that file. I will open a new Houdini session, a second session, and I will open, oh wrong, I will open the, where is it, explosion v5, here we have it. This is the downloaded file. We don't need all this simulation right now. I will go to the shop tab, and inside of the shop tab we have this shader. It's not appropriate for the current Houdini build. So what I will do is I will delete all that stuff. Hopefully it will not crash. So let's move here. So I will copy X. We'll go to our new Houdini session. We will create a new material builder right here, V5 material, and we'll copy V it right here. Then we have to delete this old volume, create a new one, and put this into the emission color and connect this to the output. So far so good. When I apply this material now to our current volume, you will see it will probably not looking correct. We don't need that here to go away. So you see it's not looking correct. This is simply because we of course have to type in the density right here. So when we restart, it will look much better. But you see, it's still not looking correct. So stop this process. And this is because the example file has a slight typo error. When you go to the Pixar prim variable 1, you see the temperature field is not called temperature, it's called temperatura. Temperatura. So this is the right way to go. And here you see you get the fire now. This is now looking much more correct. And what I usually do is I do a remap or a ramp, probably a remap first. and then remap, because this is not really suited for aces. You can dial it here, and also the colors are not looking, I mean, you can use it. I really don't like those values. So you can use, of course, like I showed you before, you can re-ramp this with the color ramp. Oh, this was the wrong one. I want a pixel ramp. So we need R and put it to right here. And here we have yellow, red, black. So because of those ranges, we probably have to look a bit. Maybe we have to adjust those values. Oh, interesting. I will place a color corrector at the end. Sort of shortcut. Oh, the overview. So you see, you have to deal with those values quite a lot until it somehow looks correct. Maybe you can. But yeah, the smoke is still white. I will dial down this one to diffuse 2, and this is more or less what you get with the default shading. It looks okay, but yeah, I really don't like that. It's looking unnatural. Also without my notes, it looks totally unnatural. So you can reshape it. You don't have to. This is the way to go. Keep in mind that you have to rename this pixel prim variable to temperature and net temperatura. Maybe this is because of a language, maybe Italian, don't know exactly. But yeah, of course, in the black body you can change some physical parameters like the intensity of the flame. You can do it also here, of course. You see, you get a bunch of fireflies, a lot of fireflies. It's looking weird. So I can check if the light source option will help here, but it will completely erase this stuff. You have to, in order to make this work, you have to set some parameters according to this tooltip. But yeah, it will have very drastic and long render times. But that's the way to go to shade a flame. Of course, when you want to add those other parameters like motion blur, we will have to do all these steps from the past. So we go into the pyro import. So we want to look at this. Okay, velocity, we have all volumes. VDB convert VDB. I create the null, call it render. And we also need a merge, VDB merge, vector merge. First of all, we have to convert it to VDB and then the vector merge. Now we have a velocity field. And inside of our shader, we create a new prim variable. And the second one is for density, as usual. We connect it to here. And well is for our velocity. Set it to vector. Connect this one to here. We will change this to here and hit the render button. And hopefully we will see something. And as you can see, it has worked. It was clamped at the top. So we go back to our pyro. We create a VDB activate. Go to the expand tab. Let us type 10. Connect this to that. Hit render button again. And now we see it's not clamped anymore. The velocity is working. So let's move the camera a bit higher. Restart. Is the animation clamped by itself? Ah, okay. The animation is clamped, or is looking like clamped by itself, probably because of the bounding box. So let us raise the padding. Or maybe we can go to use OpenCL and raise those values division size, or no, we will divide it much further with lowering this value. So let us render again. Of course, more voxels mean more pre-calculations for those velocity, and that's the result. So we can maybe raise this value to 2. Yeah, maybe. As you can see, it still works fine. So this is without motion blur, and the motion blur variant is looking much better. Okay, so, and we also can assign multiscattering. It will increase the light distribution inside of the volume, and here you have it, of course. So this is how you shade. How you shade a flame, an ordinary flame. What you can't do with that is you will not be able to shade one of those sparse pyros. Those sparse pyros, also those presets, are currently very hard to shade because those presets have those new trail subs and so on, those new options, and the complete reshade, and those minimal solvers. Yeah, those minimal solvers. It's very hard to match the look of those minimal solvers. Also, the name are renamed. The name of the fields are not matching exactly anymore. So, without any further intervention you will not be able to render them. Because of this, I'm using the Axiom solver, because the Axiom solver is working very nice with Renderman, and this is what I will demonstrate in the next tutorial. I have built an asset to do that, especially for night shots where you always have a bunch of fireflies, and I will show you how you can denoise it, how you can apply motion blur, and so on and so on. And so I hope I will see you in the next tutorial. See you. Hello, so welcome to the final chapter of this volume tutorial for Renderman. In this final chapter I will show you what I have developed in recent 12 months or so. I basically have developed a lighting tool for volumes, which is based on Houdini and Axiom. Axiom is the solver that I have used for this asset. Of course, you can also use it for your own solver and animation. It's basically just a lighting tool for volumes for Renderman. So, first of all, where you can get this asset. So I have uploaded it to my Gumroad profile. So it's called AA for Alexander's artwork, Renderman Volume Lightcloud tool for Houdini 18.5. And I also have spoken about the fact that I use the Axiom solver, and I will distribute a preset for the simulation. However, when you want to simulate this explosion by yourself, or when you want to tweak those settings, I only have used low-res settings, so every user can use it. It doesn't matter how fast your computer is, so you should be able to see a result no matter what system you have. And I will not distribute the solver itself. The solver is developed by Matthew Puchala, and he has created a website on mattpuchala.com, Axiom, where you can get the solver. Our current build, or the current build from Axiom, is version 1B004. This is also the version that I have used in this asset. When you don't have the solver already installed in your Houdini session, you should do this. It's plain simple. You download it, and when you have downloaded it, you go to your user folder, and then you copy the DSO files and also the OTL files to the specific locations inside of your home directory. I'm using Linux Mint, and that's because it should look different compared to Windows, for example. But that's the way to go. You copy the files to the correct designations in the Houdini user folder, and then you restart your Houdini session. Make sure you don't use the Python 3 version. I don't know exactly if this is working. However, Renderman isn't working with Python 3 for now. So, and what you get is, and I will also share the links in the description from the tutorial. I have also mentioned the links and where you can get it on the product page itself. It has two different price models, of course. The cheap price models for freelancers and indie users, and the studio license is when you have multiple Houdini sessions, when you have some sort of indie studio. I will only distribute the Houdini indie file, the hiplc file, because I don't have a studio build. However, it's totally open. You can dive down and can check, manipulate, and do whatever you want with that, except reselling. And I will show you why I have developed it. So The biggest reason is when you create an ordinary volume explosion, you get a lot of fireflies, especially when you have a night shot. So it's totally black night or dark and you have an explosion. Those fireflies will populate your entire shot, and you have to wait long time and have very long render times in order to resolve those fireflies. Also, the denoiser will not work or will not work nicely. And yeah, probably right here at the outer rim of the explosion, you see you have here some noise, and here it's not possible to denoise this shot. Not even with a denoising plugin like Neat Video, which should work on almost every synthetic noise. So this is not the way to go, but this is the current situation in Renderman, and it's not a nice one. So now I will show you how it should look with the asset. I will close this demo file. I have changed a couple of things to show you what the problem is. So I will go to the selling version. It's more or less the same explosion. And it looks that way. And when you hit the IPR again, you will see something different. You see something like this. This is how it should look. Of course, I don't have the reflective ground activated currently, but I will show you in a second. You see the noise distribution is very fine, and the result looks very realistic. This is something you will be able to denoise, and you will have a really nice quality. I have done this with this example explosion that you also get in the download. So you get the entire pre-simulated BGOSC sequence, has a size of up to 6 GB, and yeah, you can load it. You have to redirect to those file caches, and then it should work. So you can test if it's working or not for you. And I will show you the result. I can use the composite view to make it plain simple. I will go here and I will show you the denoised result and the not denoised result. First, where is it? Somewhere in my Houdini folder, of course. Here we have it. Render F. So on the left side we have the final explosion. Okay, and this should be the not denoised version. So this is that's the denoised one. I want to see light variance. This should be okay. So this is the final render version. As you can see, the noise distribution is very even. I can that's the wrong one. Oh, sorry. We can dial this down, so we can even change the that's the gamma, I guess, the brightness, and you see we have a lot of detail in the shot, in the simulation, and it looks very nice. Of course, we have some noise in those trails. This is because I have only used 48 samples in the render process itself. So when we go here, those are my settings. Very basic, nothing special. Render times, something between 6 and 10 minutes per frame. So those small explosion parts are rendering very fast. The first 10 frames or so, only 2 minutes. and then more or less at the end of the explosion right here, it will take much longer. What you already have seen is that we still have some noise issues, but it's totally okay. We also have some problems with overbrighted pixels. I don't found a solution yet, but this is very minor. I mean, in motion you will not see it. The denoiser will also delete it. I have used Neat Video, so this is not the problem. It's just because of the trails and how I made the setup itself. And now I will show you the final result. And for that I have to overwrite the start frame. And I have to change to 1001. And then okay, now you see it. I will zoom out a bit. I have added some motion blur to it, so I will add also some frames right here. I have added some motion blur in compositing. I have denoised it, and when we go to the final color, you see the denoising is working almost perfectly. And this is because the noise distribution is very even, so there are no gaps in it, and it's a logical noise distribution. I also have used multi-scattering in it to get faster render times. So with multi-scattering it results much faster, even when it should render slower, but indeed with this lighting asset it will render faster. When you have a situation like this, I cannot guarantee that this will work in all shots or in every case, so keep that in mind. This is a very hard situation and it's optimized to work in those situations, but of course it will also working on a day shot. So like I said, this is the result. It looks very nice. Also those problems are gone right here. It's a full HD shot only, but it's just for testing. You can render it also in a larger resolution. And you see, even at the explosion, at the first frames that you probably will miss when you look at it in real time, you see that the explosion occurs more on the right side and the light is much brighter on this side. So it's very, I will not say physically correct, but in artistic sense very accurate to what you see from the artist standpoint. So this is what you get. I will move to frame 1 and I will delete those stuff. So, and now I will show you what I did with in preparation with Axiom to make this work. And for that I will go into this preset container. Every time when you want to change the simulation, you should use this container. So you can create your simulation in another container or in another geometry object, but at the end when you want to work with this lighting asset, you should copy everything inside this object, or alternatively you should check all those settings and make sure that you have the exact same settings. So what we see in the first place is I have raised the micro polygon length to 3. I did that because Renderman doesn't need a value of 1. Value of 1 is, you can imagine it like slices through the volume itself. So the accuracy on the volume is much larger at 1 and lesser on 3. However, from a visible standpoint, there is no much difference in 1 or 3. On the other side, setting it to 3 will speed up your entire render process by itself. So less data, faster results, faster updates. This is highly important to have fast feedback. And I have also changed some other parameters, like I have deactivated the indirect visibility. This is the cause for all those fireflies. And we don't need that because my light is basically recreating what the indirect light should do from the volume itself. So I've also changed the material path, of course. The rest is default. I will describe this shader later. For now, we dive into this object, preset object. So I will raise this screen here. So I will enlarge it, and I will show you what I mean basically. When you open this preset, you see that this, or more or less this, is the default explosion preset from those new Pyrosparse tools or minimal solver tools with those preset. In that case, it's the ground explosion. So I've made some tiny colors, fancy colors here, and some boxes to have a much more better overview. And I have exchanged this explosion center with the scatter to just a line. So those are my changes, but this is more or less what you get from this button. And when you do this, you get a really big amount of additional stuff at the end of the volume rasterizers. You can all delete that when you create a new button. So what I mean by that is, let us create a new geometry, and we will just create the explosion, the ground explosion again. I will set it to here. It will calculate. Hopefully it will not simulate. Okay, it's working. So now we have a dot network, ground explosion stuff, and so on. We are using Axiom, or I use Axiom, so I don't need that. But when you go inside this ground explosion, you see you get this split trails and you get this one. And this one, when you use Axiom or when you use Renderman, this can be deleted. In fact, this can also be deleted. And this is the only thing that you need from this. And this is what you copy. You delete that, you copy it, and you basically copy it right here. What I have added in this preset is a ground blast, which is more or less a copy of the trails. I have changed some parameters. So we have a start frame. I will go into this step by step now. So this is our line. We have initial frame and the offset frame. And we have a pyro burst source, which is a copy. I have changed some of the parameters right here, but when you play it through, you see that. And this is not a ground burst in any way, but I have changed the colors for this so that our colors are working. This is my custom setting more or less, and I use the attribute burst ID for reshading those. And then I seriously found no way to make it possible to distribute this pyro burst source only central on the ground. I think it's not developed for it. I found it very complex when I dive into this asset, so I thought there's an easy way, and the easy way is I use a copy points, copied some grids to the offset starting frames, and more or less reprojected those point clouds to the ground. And this is what you get right here. In fact, I only would need one grid, but what is when you have an explosion right here or here or here? It should work anyways. So we can probably exchange that just for showing what I mean. So we can go right here to 100, or let us say 200 maybe, with 4 explosions or so. And then when we go here, you see you have 4 different explosion centers, and of course 4 different shock waves on the ground. Each one has a different color. You can vary it here, right here. So in case you don't like that, this is basically the first one, second one, and so on. You can change the colors like you want right here. Then reproject it. Then, very important, I've created a new trail sub, because the velocity that you get from the pyro burst source doesn't have any value anymore, because we have changed the overall direction. So what I mean by that is, this is the direction that we need, the vectors from the velocity itself, and those are the values that you get from the pyro preset. And this is, when you only would reproject it, you will see it will look totally wrong, and so the trail sub will fix that. And then I have funneled it into the merge for sim, the main blast, of course, 2. And here you have those different explosions. Let us move this back to here where it should be. So this is what we feed into the Axiom solver, and of course also the trails. So those are the trails. This looks much bigger because of the velocity field. This is the correct density. And then, like I said, when you do your own explosion, just copy it here and connect those to those nulls, plain simple. Those are the collision objects for the Axiom solver itself. And to make those fields, those volumes, workable in Axiom, you have to rename those fields. This is something Matt provided me as support in order to get this asset working with Houdini 18.5. So you have to rename this, and I more or less did that here. So the trail density becomes density, burn becomes fuel, and trail temperature becomes temperature, and CD becomes color. Keep that last point in mind, that's heavily important. CD is now color. And for the trail, it's more or less the exact same. So as you can see, same stuff. You can use it, you don't have to. If you don't have the field, you will probably get a warning message, but nothing else. In the solver itself, I have divided the simulation into 2 solvers. One for the blast itself, and one for those trails. So this is the preset that I deliver. Of course, you need the installed Axiom solver, and this is currently running on on GPU. And yeah, and this is what you get, what you see. And I did the same with the trails. I have different voxel amounts, memory efficiency turned on, and changed some of those parameters. And yeah, of course, I have added some boxes here also, where you can some hints into the Axiom solver itself. Then, heavily important, the Axiom solver works more or less the same like those new Houdini post-pyro shading effect stuff, how you call it. And because of that, I have deleted the temperature field. So when you deal with the trails, they are so tiny that it can happen that those tips are not glowing in, let us say, the first frame, the second frame, and so on. And because of that, and because of the problems in the asset itself, I have bypassed this temperature field. So more or less, I only use the density and the velocity, bring it to the pre-volume for render, which also comes from Axiom, and in the final shading process, I used the bypassed color, or in that example, I bypassed also the color because we don't need the color. But in case you want to do that, you bypass the color as a separate input, and also, of course, the temperature field itself from the source. So this is working. Because of that, I bypass this to the render process itself, and then when we look into that, we get color information, we get density, we get temperature, we get velocity, scatter, trail density, and here trail temperature, and trail density, of course, and velocity is of course for everything. And this is more or less the result. And yeah, it's it uses nano VDB, and it looks a bit weird probably, but it will look right in the render process itself. It's very fast. And yeah, this is what you have to do in the explosion itself. And now I move over to what disadvantages of these assets are. So, or how can I say that? The asset is not physical correct in every case. So there are some limitations, very few limitations, but you have to know them. And for that demonstration, I will turn the ground into something reflective. So I will copy it right here and call it ground reflection. Oh, I don't need to do that. I can use the test sphere with reflection. It's plain simple. So let us go here and we use the reflection sphere. Yeah. So I will re-hit the render IPR. And you will see it will start. And you will see that the reflection of the explosion is not entirely correct with the volume itself. So why we have those gaps in here? This is simply because this asset basically create a mesh light, and for each voxel on the outside field we create a lamp, and we also create a shadow caster. And this will lead to the situation that the reflection is not physically correct when the reflecting objects are not that large in the screen, or when you have a shot in motion, you will probably not see it. You can also fix this stuff in post, and yeah, nobody will notice. So if you don't know it as an audience, you will maybe wonder on closer look, but yeah, you will probably accept it. So when you have a reflective, when you have the explosion reflective on the ground, on a water set or something like that, you have to keep that in mind, that we don't have indirect rays, and indirect rays is this what is showing us the reflection in the volume in the reflection. So, and I have restarted the entire render process, so you will see it, hopefully. And you see those gaps are filled now with volume. Of course, the intensity isn't matching, but those gaps are filled. But you also see, of course, fireflies are appearing when you activate indirect visibility. and this is not what we want. This is a fail in my eyes. So deactivate it, lock it, and fireflies are gone. That's the way to do it. So gaps reappearing. Yeah, like I said, this is because I have built a light emission mesh light, however you want to call it, and it will generate it in the light generator, and all those data will be funneled to the Pixar mesh light. I use the mesh light because the mesh light is working, the volume light isn't working in all cases. I had serious trouble with the volume light inside of Renderman, so this is nothing that I want to use in production when it's not working all the time. Or maybe, I don't know, maybe someone can help me, but I found no way in order to make sure that the volume light is working in every case. So also the volume light is very, very slow because it will turn every volume voxel into a light emission field. And yeah, my solution creates a mesh light. I have developed a very efficient mesh light. The resolution don't contribute to, or higher resolution of the mesh light don't always contribute to longer render times. Probably you know this from Mantra, where mesh lights and a lot of mesh lights will create long render times. This is not the case for Renderman, at least not in my experience. And this is also because of the algorithm itself, the render algorithm. And yeah, I will dive down now into the light generator to show how you work with it. So first of all, you have the importer, which is importing the final cached animation simulation, and this is driven more or less by the input of the Pixar mesh light. So what you insert right here will be inserted right here. So this is what you do. And here I have created some tiny controllers. And I will show you now what those controllers are doing. So right in here I have created those subnet boxes. The reason for that is to keep it simple for you. On the other side, I don't use those subnet boxes anymore because I don't know why, but subnet boxes in 18.5 on Linux will slow down your entire calculation process. I don't know why, but this is currently the case. Because of that, I turned away from subnet boxes and moved over to those network boxes. It's more or less the same. It makes it simple, looking simple. So the first one is plain simple. You define the naming of your simulation fields. For that, lighting, we only use or need density and temperature. We currently, or for the lighting, we don't need the color by itself, but of course you can add color influence to the lighting process by yourself if you want. You have to do it manually. Maybe I will do it in the future, don't know, but it's currently not planned. I see no reason for that. And yeah, more or less you can leave it at the basics. Also for a traditional Houdini volume, this is first step one. So you follow the arrow, which I created here. You follow down the curve and you go to step 2. And you can activate step 2, and what you see is right this, and this is more or less the result or the source for our light field, when you call it light field. And what you have to do for using it, you have to define the frame where your explosion had the biggest expansion. So when we go back to our volume, and when I activate those volume boxes, you see at frame 1100, we have the biggest expansion. And this is more or less what you define. You can do this automatically. There are functions for it. I have used them in the past, but yeah, in most cases you run better when you do it by hand. You can use a measure sub, for example, to measure the volume size in order to get the right frame, but this can bug on changes, and this is the secure way to do it by hand. And yeah, and the second thing that you need to do is you have to define the grid division. So when we go back to this asset, of course you have to have a temperature field. So at the end of the animation there is no temperature anymore. The temperature is gone, and this is because you don't see something. So we go back to a frame where we have some emission or temperature, and this is the default value grid division of 150. You of course can go down to 75, and you see you have a lot lesser density. So default is 150. You should use it. In most of my tests 150 is enough, and also fast enough. Of course you can go higher. And the second thing is the scatter field itself. So the scatter field density is more or less the source density of I basically transferred the volume information from the source volume to my static grid. You create a static grid in the end, or the asset do this. Yeah, this is the source from where the information of the temperature comes from, and those are the settings for it. They are working most of the times. Of course you have some I have added a blur function and a threshold to it to minimize and avoid flickering, because the static field of course is static, and the animation is a moving volume, and when those voxels, when they don't sitting on top of each other, you will get lesser value, and this could lead to flickering. And because of minimizing flickering, I have added those blur functions, attribute blur more or less, and those settings working in most cases, of course. And then you go to the next control button, which is the hull control, and here you basically define how much away or how far away this emission light field is. It shouldn't have a too large distance from the field itself, but also not a too tiny distance. In all of my tests, the distance of 6 or the offset of 6 is enough. So when I set it to 10, you will see it will move more outside of the volume. So the problem with that is when you have a too large size, then you get an illumination gap. And this is one of the not accurate things inside of this asset. This is something that you also have to keep in mind. But on the other hand, it can be resolved with multi-scattering. So multi-scattering is the way to go. So I can go back to last week, and we go to, that's the wrong one, where we have it. So we have it here. I guess it was the first or second or third. I guess it was this one. So when I open this one, you will see, or maybe not see. Oh, okay. We have to activate ACES. So, and yeah, what you see more or less is this is the illumination gap that I'm talking about. When the range is too large, you get this gap, and it should has a decent distance, and this is in most cases 6. This is one of the old examples, like you've seen in the last iterations. It was resolved with multiscattering, also with some changes that I will talk about in a couple of seconds. But this is more or less what this distance means. And this is the second value is the width of the hull itself. So you of course can make it much thicker. That means also more lights. And yeah, probably you don't see that. Okay, yeah, okay, yeah, this has more thickness, so also more lights will distribute it. And also because of the entire process, you also have an ISO hull offset. So now we move over to the next one. So in case that I do a mistake, I will call it demo 2, autosave and so on, just in case I make a mistake. Yeah, demo 2. And now we come to the next stage, and the next stage is quite simple. It's basically defining, it defines how those temperature values will transfer to this resulting point cloud. And those values are working with the Axiom settings, maybe on a Houdini simulation, or when you use another solver, or when you have another color space, you probably have to change those values. It has something for reshaping the initial source volume. So this is basically the source where the information comes from, and you can reshape this source volume. This is happening right here. It's just a volume ramp, nothing special. And then you will get to remapping, and the remapping occurs right here in the attribute from volume transform, and there's also some deleting the threshold, of course. This is also set to make sure that intersections get resolved. So this is the first step for resolving intersections of those light fields with the volume itself. And then we have some p-scaling and some attribute wrangles or volume wrangles, some other stuff, another attribute blur to blur those values. And then we have the final intersection resolve, which is more or less happening right here. So here you have two different approaches, one VDB approach and the SDF approach, to get rid of every intersection. And why is this important? In the past, many artists tried to create a volume light for Renderman, and all around the time we had the problem that we get an ugly looking flickering. And this is what you get right here. You see, you have here some points, very bright points in this frame, in that frame. And those points are the result of light intersections. So those lights are moving inside the volume. And because of the distance to the light source itself, this will get very bright. And this creates a lot of flickering. And it indeed looks horrible. And yeah, to get rid of this, this is the solution. So the intersection control. Change those values. They should work. Maybe not in your case, but yeah. And the final stage at the end, this is the last step that you have to do, or the second last. When you change the density here on top, the grid division, you probably should also change the emitter scale. It is not necessary. So when you use the defaults, you can leave it at 1. When you have a much thinner distance between each point, you should scale them down. You have to make sure that no lights are sitting on top of each light or nearby. This can cause flickering in the lighting process, and it's also not necessary because it will slow down render times for nothing. So I can't imagine a case where you need a much higher density, but maybe you need that. So I have the option for you. And at the end, I have something. This is not that important for you, but yeah, maybe yes. This is the light density scale. So the light density scale is more or less a scatter representation with a point count. So the density field a scatter sub will create points inside of the temperature field, and the amount of points is the driver for the light intensity of the pixel mesh light. So it gets more or less funneled or fetched to the light intensity. And this is more or less what, when there's no temperature, when there's no fire, no points will generate it. And because of that, no light fields will generate it. And because of that, it will be dark when there's no other light. So this is the reason, and you should leave it with that. I have changed the exposure value, so this is your fine control for matching the look and the brightness of your flame volume shader with the light emission in your scene. So this is more or less your manual control to match how bright this flame really is. And when I say really is, then I mean how the flame or how the volume is looking without this mesh light. How it should look for you as an artist. So of course you can make it insanely bright. On the other side, there's quite an important factor because I have activated area normalized. This is for reason, because this will avoid or will destroy any big flickering when you have a very tiny amount of points. So more or less in the early stage of the explosion and at the end of the flame. So this should be activated. I have also activated trace light paths. In my test, this was much faster than the default value. And the biggest reason for how it will look correct is those light blocker. So when we go back into the light field, you will see that I have an emitter, copy to points, and I have two export results. The left output will create the lights, and the right output will create those light blockers. Those light blockers will make sure that those light fields from the mesh light will not illuminate the volume itself. And because of that, this is important. So I can show you this directly right here. So first of all, we will deactivate those light fields and those light blockers, and I will start the render process. And we'll also go to ACCG. And you will see a very intense flame. The flame itself is probably the intensity is much higher than the flame volume by itself. So you see it's plain white. And this is because the mesh light is distributing light into every direction. I have used a very efficient light source, so the mesh light source for the point distribution is very efficient. However, it will create this stuff, and there's no way to fix it as to separate it into a second object. So, and I will activate this one, and I will activate the light blocker by itself now, and you see it's much darker. You see much more detail. So when I dial down the exposure, you see there's a tiny gap in the brightness of the left side and the right side. And this is just because of the light blocker. So here you see it very clear. There's really too much light on the flame itself on the right side. So that's the way to go. That's because we have a light blocker. And finally, I will go to the volume shader by itself. It's a very basic volume shader. I have not connected the color volume at the moment because for this one we don't need that. And it's also, it's not that easy to shade. Because of that, there are a lot of ramps and clamps and so on. You have to change those values by yourself until it matches what you imagine. So this is the base color. We have to have a base color. So when you don't have a base color and use temperature and use the color information, you will overwrite the volume color, the diffuse color. And this is problematic because the flame will turn very dark, or the transition area will turn very dark. To minimize that, you have to have this sort of thing. So, but in this explosion I don't need that, so I have deactivated this. You only have to connect it from the result RGB to the diffuse color in case you have this field. This will also speed up the render process quite a bit. This is the velocity, as I have mentioned in the previous tutorial section, and this is where the magic is happening. I'm very thankful to the Renderman community by itself, especially where is the useful file section? Right here. So when I dial up, scroll up, you will see the username Iha Abali. He's a very nice person and he has contributed ideas to create a Renderman shader. And I changed quite a couple of things, and I have also, so the shader by itself is available for free on the Discord server. I share it in the useful file section as always, also the basic PBR material setup and so on. A lot of nice stuff for the community, how you use mesh lights with random light scatter colors and so on. And so when you be a member of the Pixar Renderman for Houdini server, you have free access to it. I invite you to join here as well in case you have questions, and of course we have a help section. Back to topic. So this user has provided the initial shader, which is free, and I have integrated a lot of stuff for making it work with the Axiom solver, with the latest updates of the Axiom solver, and also with the trails that Houdini 18 has introduced, or side effects in Houdini 18. And this is the basic stuff. You probably don't have to change anything in the shader. It more or less works in most cases. In case you want to raise the exposure of the flame, you only have to go into this box, into the Pixar Color Corrector 1, and have to change the exposure. And when you want to raise the trail temperature, so basically the tips, those trails, you use the same intensity or exposure volume like the flame, but you can change how it appears in the Pixar Color Corrector 2, which is more or less an input mask for the final color corrector. And here I have changed some stuff and make it brighter so that it becomes a really good mask. I have changed the input range, and here is quite an important step. In order to have a correct looking trail tip, you have to go into the negative. I don't know how to fix it better, but the input range shouldn't be 0. It should be lesser than 0. When you put it to 0, you will lose all those glowing tips. So this is important. The rest is default. Of course, the RGB gain will define how those tips will look. Oh, yeah, you have to match your explosion or your lighting. And yeah, that's the volume. And yeah, finally I will show you how I have denoised it. For the denoising process itself, I have used Neat Video. I highly recommend to use Neat Video. I use it in DaVinci Resolve. This is not necessary, so you of course can use the normal Houdini or the Renderman for Houdini denoiser, the ordinary Renderman denoiser, like I have shown in recent tutorials. But I moved away from it because Neat Video's latest results are providing much better results. So yeah, especially when you have an RTX card. Don't know why exactly, maybe the speed or the accuracy, but yeah, this is the way to go for me. And yeah, of course, when you load in your explosion, why is this black? Maybe a bug. This is a recording bug, I guess. This happens always when I record a tutorial in the latest build. Don't know why, but yeah. So, but yeah, this is the final result, and I have denoised it. And the way to denoise is quite easy. You have this ACES. You have to drop down the ACES transform, and you have to, this is your controller. Before you output it to your Houdini, to your compositing session in Fusion or Nuke, you have to deactivate this node so that you go back into color space of ACES and not the converted Rec 709 that you have to use inside of DaVinci Resolve. So this is looking ugly currently, don't know why, but yeah, it looks very clamped. But for denoising, the denoising process is quite easy. All what you have to do is you create a reduce noise node. This is the latest version 5. You connect it right here. For controlling, you activate it, of course, and you go to prepare noise. And then you probably get some errors here. This is because the Neat Video plugin can't resolve pre-multiplications, so we don't have to care about that. But we only have to, plain simple drag and drop about the explosion itself, about the volume, not somewhere here, but about the volume. Of course, highly likely that this will not work in the first try, but we will try it. And we get this result, and here you see it looks quite nice, but we have some tiny noise right here. We activate adapt to changing noise, and I set it to higher, so now it looks much better here. And of course, like in normal footage denoising, we can change with those values. And yeah, I kinda don't like that picking that I did right here. Maybe we can go here. This looks much better. This looks really good. And maybe, yeah, you have to find 2 is in most cases the best version or the best way to go. And then we probably reduce the local blurring a bit. And yeah, this looks really nice. So yeah, no offense against the Renderman denoiser, but this is what you need. And when you play out the delivery, you only have to output the format to EXR, then you go to DWAA compression, which is from Sony ImageWorks. This is the better one, this is the not so good one. And float value is important. Of course, you can also use zip and PIDs for much higher file size, but yeah, I use this one. This works in most cases also for good compositing. You should activate the export alpha to pre-multiply, check all the other settings. Also make sure that the data levels are set to full so you don't lose that much of quality, only high quality resizing and so on. And yeah, and then you render it out to your compositing tool. And when we go back to our explosion inside of Fusion, we will load the latest explosion, which was iteration 5. This was this one. And I also load in the denoised 3 version. This was the last one. So let us check. This is the not denoised. This is the final render result, the raw render result, and this is the denoised result. And what I usually do is I do an average between both. This is also what you do in every normal denoise environment, or what you can do, not have to, but you should do. So the reason for that is quite simple. The denoised version will lose some tiny detail, and in order to reduce those tiny detail loss, you average it with the render result, which will of course introduce more noise. And what you can do is you go basically back and average the denoised result over it again, and then you do this again. You can do it how long you want, but yeah, it will create an average between both of those steps, and this will introduce a better quality. And of course, when you do this too much, it will not work anymore. But so this is the averaged result, and I will copy it, and this is the plain denoised result, and you see it has, yeah, it's much more blurred. Here you have more defined edges, but it still looks better than, yeah, not denoised. So that's the denoised one. Oh yeah, that's the denoised one. It looks horrible. So yeah, that's the way to go. And then of course you do your ordinary compositing, your retiming, and yeah, you use those vector tools, of course, optical flow tools I mean. And there are a lot of ways to create explosion, and yeah, the final result is what you get from what you get also on Vimeo. And yeah, this is what you want to have. A very nice looking explosion and illumination of the surrounding environment. And yeah, that's the asset. Like I said, you can get it on my Gumroad page with 2 different license options. I have also described where you can find me and where you can find Matt Buchala. I highly recommend to support his development. Axiom solver is maybe not that fast like the new minimal solver, but Axiom provide a very nice approach of creating very nice and realistic looking explosions without very large and complex settings. It works out of the box. Matt is also distributing some examples like a flamethrower, a rocket launch, and so on. And yeah, you can get it. I will share the link, and I will also make aware that I have created a new system on Gumroad, or Gumroad has introduced it in a recent year, where you can directly support my work, also for creating tutorials and so on. You can pay it on monthly basis, yearly basis, whatever you want. You also have those tiny pluses right here, and those tiny pluses indicate that you can contribute and what you want, the amount you want. This is just the minimum amount. So you can go to subscribe and help me in order to create more tutorials, help the community, help the Discord server, which also has now a bot which helps me in order to organize this large growing group of for Houdini users. So, and become a part of it. And of course you can support me. And what I really like on this new Gumroad system is that you also can hire me. So this is the last thing I want to show you. You can go to my product page, and here you have it on a second product. And here you can also go to the Renderman for Houdini exclusive support and consulting tier. And this means I will provide you 1 hour of my time to support your commercial or private project with all my experience in Renderman for Houdini, of course, also experience in Houdini. And there are already some subscribers, and I will help them to when you have a problem and you don't know the answer, you can hire me for 1 hour. Of course, you can also hire me longer, but this would require a contract, a working contract, a project contract. And I will also sign an NDA in case this is needed. But of course, you can only support the Discord server, but you can also get the exclusive support from me. So this is what you find on Gumroad itself. And I hope you have and had fun with this tutorial. I hope you have learned quite a lot about volumes. I struggled with volumes in Renderman quite a lot in the past, but since Renderman 23.5, I'm very happy with Renderman and volumes, because they are rendering blazing fast compared to older versions, and also there's a nice shading with Axiom solver, or the Axiom result provide a very good entry point for the Renderman shader. And so this is the way to go in order to get a very nice looking explosion or fire or whatever you want to render. Stay healthy, and I see you in the next tutorial. See you. Bye.